In this video, we're going to talk about logical arguments. So let's add some definitions. The first one is a premise. So a premise is a statement that is accepted to be true in order to form a conclusion. An argument is composed of a set of premises and a conclusion. An argument is valid if the conclusion is true when the premises are true. An argument is invalid if the conclusion could be false when the premises are true. So probably the easiest way to start understanding this is to give you an example. So here's what I have. If you have a daughter, then you are a parent. You are not a parent, therefore you do not have a daughter. So this is an example of an argument. You can see the first statement is a premise. The second statement is also a premise. Many times as I give you problems or as you're doing the homework, you'll see there's a line that separates the premises from the conclusion, and there's usually also the word therefore that indicates we've gotten to the conclusion. So all three statements together form the argument. The conclusion is not the argument, the premises are not the argument. It's the set all together, that's what we consider an argument. So to test the validity of an argument, we need to do a bunch of things. So the first thing we should do is write the statements in terms of symbols. Once we've done the symbols, the argument is formed by joining the premises with the connective and, followed by the implication of the conclusion. So let's say we had two premises, P1 and P2. The conclusion is C. The argument would be P1 and P2 implies C. Notice that I have the and with the premises, and it will always be and between the premises. The conclusion will always be separated afterwards by the implication. If the argument forms a tautology, meaning I get all truths when I test the argument, then I say the argument is valid. If the argument has any falses, then it is invalid. When I'm talking about the argument having any falses, that means the very last column where I'm looking at all the statements put together with the ands and the implies, so I know there will be some falses in the truth table. What I want to get to is that very last column that stands for the argument and see if I have any falses there. All right. So let's go back to our example that if you have a daughter, then you are a parent. You're not a parent, therefore you don't have a daughter. Do you see we could write it this way as symbols? So I have my P implies Q, there's the first statement, not Q, my second statement, and then back to my not P, which is my conclusion. So I need to turn the statement into an argument, which would mean I put the two things above the line, those are my premises, the P implies Q, along with not Q. See how I put those together with an and I've kind of put brackets around them just so you can see they all go together. And then later I have that imply, not P, the conclusion. Okay, so I need to make a truth table to test this. So here's how I made mine. I started with P, Q, then P implies Q to say there's my first statement. Then I have not Q, my second statement. Then I put those two things together. So those are my premises together. Finally, I have my conclusion, not P, and then the whole thing together, which is my argument. So we should know by now that P is true, true, false, false. Q is true, false, true, false. P implies Q. So remember, true implies true is true. True implies false is false. That's the one we're really thinking of with implies is true implies false is false. Everything else is true, which means anything that starts with false is immediately true. Okay. Now not Q. Not Q is just the opposite of Q. So now I have false, true, false, true. I'm joining that P implies Q with the not Q. My connective is and. And says I need all truths. So here, true, false will be false. False, true will be false. True, false will be false. True, true is true. Okay. Then my conclusion was not P, which I know is false, false, true, true. I'm putting these two columns together. Again, I'm using the implication. So I say false implies false is true. False implies false is true. False implies true is true. And then true implies true is true. Now you can look at this last column. See, I have all truths. That's a good thing. That's a tautology. Anytime I have a tautology, then I say my argument is valid. Okay. So let's try it again. Here's a second example. It says Tom gets a raise or he quits his job. Tom didn't quit his job, therefore Tom got a raise. So my very first thing I think to do is turn that into symbols. So now I have P or Q, I have not Q, and then I have my conclusion, which is P. Okay. So I take my statements, they go to symbols, symbols become an argument. So the argument is the two statements together above the premise, above the conclusion. So I put the two premises together, my connective is and then implying the conclusion. So really important, this is always and, really important, this is always implies. All right, here is my truth table. So again, I have P and Q, which I know. P is true, true, false, false. Q is true, false, true, false. My first connective is or, and or just says I need one true. So true, true is true, true, false is true, false, true is true. Okay, I had a true in each of those. But the false, false is false. Not Q is simply reverse Q, so I have false, true, false, true. Now this time, I'm connecting my first and second statement. I'm connecting them with and, so I know that I'm saying anything with the false is false. So true, false is false. True, true is true. True, false is false. False, true is false. I'm repeating P. You don't have to. Just so you can see them side by side, and it'll make it easier to do this implication. But you could have left that off. That's fine. So I have false implies true is true. True implies true is true. False implies false, true. False implies false, true. All right, so once again, I gave you another example where I got all trues. That's a tautology, so I say my argument is valid. Okay. I can definitely add more statements. So this one has a P, a Q, and an R. It doesn't matter that I didn't put words in here. I'll put words in some more later. I just wanted you to see what happens if I have three statements. So here I have P implies, parentheses Q or R. I have not Q or not R. And then I have my conclusion, not P. Okay. So even though this is way bigger, it's still okay. I'm still going to do the same thing. I'm going to put the two statements together that are above the conclusion, and I'm going to connect them with and then I'll imply the conclusion. So you can see this big thing down here. I have kind of double parentheses going on, but this is what I want to test. So here's what it looks like. You'll see I did some second sets of symbols as well because the things just got really big really fast. So let's start with what's normal, P, Q, and R. I know P is 4 trues and 4 falses. I know Q is going to do 2 trues, 2 falses, and then R is going to go true, false all the way down. Just because I could and because it was easy, I went ahead and put in the not Q and the not R. So the 2 falses, 2 trues, and then false, true all the way down, just because let's do the easy stuff, get out of the way. All right, now I can come in and talk about Q or R. So I'm going through the second and third columns. I'm using the connective or, which says I'm just looking for a true. So I have a true, a true, a true, and then those are 2 falses. So I know what's going to happen there. And then I see it repeat, true, 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 and 2 falses. Okay. Now that I have that column done, I can put this column along with the first column, and I pay attention that it's implied. So true implies true is true. And you can see that happens 3 times in a row. So true, 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 true. Then I have true, false, so that's false. Then the next ones, false, 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 false. I can just immediately go over and say those are true. It doesn't matter what happens over here. Anything that starts false within an implication is true. Notice underneath here, I put a 1. That says this was my first premise when I started this thing out. Over here, I have a 2 to show this was our second premise from our original argument. And I'm putting these together with or, which says I just need 1 true. So the first 2 false means it's false, but then I have true, true, true. And then again, I have 2 falses, and then true, true, true. I really do look for patterns here. It really helps because there's so many trues and falses. It's easy to get confused. So I want you to look for like things that will help you make it easier as you go. All right. Now I'm going to put the 2 premises together. Again, the connective should be and I just wrote 1 and 2 so I wouldn't have to write all these symbols again. Here, when I'm thinking about and, I think I need all trues. So this true false is false, but then this is true and this is true. And then once again, false, true, that's false. True, false, that's false. But then I have true, 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 true. So those are true. I wrote not P here. This is our conclusion. So it's 4 falses and then 4 trues. Nice to have it side by side because it's hard to look back and forth sometimes. So I'm thinking I go from 1 and 2 over to not P. I'm using implies. So false, false is true, but true, false is false. So once I got to the second line, I immediately know, hey, this is invalid. It's just in this last statement that puts the whole argument together that I decide valid or invalid. You could stop there. That's perfectly okay. Or if you wanted to, you could finish it off and see that, again, you would have true, false is false. Then false, false is true. False, true is true. And then all these trues are true. But it's up to you if you go beyond that. All right. So let's do what you try. I have 2 of them. The first one, we're going to break it into pieces. So the first piece, we're just going to make up the argument, make sure we are on track of what we're supposed to do. And then the second part, we'll do the truth table. So look at this argument I gave you. If you break your lease early, then you will forfeit your security deposit. You do not break your lease early. Therefore, you do not forfeit your security deposit. All right, so here's a good time to pause. Write down your symbols, turn the symbols into statements, turn the statements into an argument, and then come back and check and see what I did. All right, so here are the symbols I used. I said P is you break your lease early, and Q is you forfeit your security deposit. Then our statement is P implies Q, then not P, and then not Q. So there's our statements. Our argument is P implies Q and not P, therefore not Q. Now we're ready to test this. So before you go on, stop and make yourself a truth table. Test this argument. Test P implies Q and not P implies not Q. See if you get it to be valid or invalid, and then check out what I did, and let's see how it went. So here's my truth table, and yours could look a little different as far as the columns go. It's just that last column that we're really looking for. So I have P, true, true, false, false. I have Q, true, false, true, false. I have not P, false, false, true, true. I have not Q, false, true, false, true. All right, so let's go to P implies Q. That's true, false, true, true. So true, false, true, true. And then put that together with not P. So true, false is false, false, false is false. True, true is true, and then true, true is true. Now I'm going to take this column and I'm going to put it together with not Q. So I have false, false is true, false, true is true, but then I have true, false, that's false. You can finish true, true if you want. But anyway, when I get to this one where I have a false, I can tell you the argument is invalid. Okay. So let's try it one more time. This one I have your home insurance rates will decrease if you have a security system or you install impact windows. Your home insurance rates will decrease and you did not install a security system, therefore you installed impact windows. Once again, take this in steps with me. The first step is just come up with some symbols, make those symbols into statements, make that statement into an argument. Be careful with this one. I know there's like a little twist of words I did in here, and I don't want it to snag you up. So only do the writing the symbols. Don't go to the truth table till we come back and check together. All right. So normal symbols. I said P is your home insurance rates will decrease. Q is you have a security system. R is you install impact windows. Here's where I think you could get a little tripped up is the first statement. Do you notice where this if happened? If wasn't at the beginning, it was down here. I didn't do that to mess you up or trick you. It's just like the statement that came in my head to do. And I think it's really normal for people to move if around. But if is what starts the statement. So when I do this one, I don't start with P. I go over and start with Q or R. So the if tells me what gets implied. So I have Q or R implies P. So if you need to fix anything, go ahead and fix that on your paper now, because I do think that was a little harder, but still good. Then the next part is straightforward. Then I have P and not Q. And then I have this conclusion of R. At least the conclusion is small. Right? The whole thing as a statement is right here. Q or R implies Oh, I kind of wrote that too big. Let's see if I can. I was trying to cut and paste there, and I think it messed me up a little bit. So this is what I need. Q. Oh no, that was right. Oops. Never mind. That was right. P or R implies P. That's the first statement. And P and not Q, and then implies R. So I was thinking, oh, I made that too big, but I didn't because I did copy paste. So I put these two together with an and then implies the whole thing. So this is a lot that we're going to test. So I do say again, stop, make your truth table, see how it goes, and then check my truth table too so we can see if this is a valid or invalid argument. All right, so here's this big old mess. I have P, Q, and R to start us off, and those are really basics. You should know it goes fours, like 4 and 4 for P, 2 and 2 for Q, and then 1 by 1 for R. I went ahead and put not Q next to it, so false, false, true, true all the way down. And then I looked at Q or R because I'm going to need that soon. So Q or R says true, 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 false, true, 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 false. Because I'm looking, I need true. So you can see that's what I have here. True, 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 false, true, 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 false. I want that to imply P. So true implies true, fine. True implies true, good. True implies true, good. So I have 3 trues right there. Then false implies true, good. True implies false, that's false. True implies false, there it is again, false. True implies false, false. False, false is true. Okay. Then I have P and not Q. So, and I'm thinking I need all true. So here I have true, false, false, true, false, false. And then I have true, true is true, true, true is true. So you can see I have false, false, true, true. Then the next 4, when I'm looking at P and not Q, I see all these falses. I'm just going to put the falses in. I didn't even look at not Q. All right. Now I'm looking at these 2 columns together. Again, my connected is and, so I'm looking for trues. So true, false is false. True, false is false. True, true is true. True, true is true. False, false is false. False, false is false. False, false is false. True, false is false. So lots of falses. All right. Now I'm ready to go back and do the last thing, which is put this together with R. So R is right here. So I have false, true is true. False, false is true. True, true is true. But now I have true, false, and I could stop. Right? This true, false right here makes the whole thing invalid.